Okay, for this problem, we're going to find the limit as x goes to infinity of x to the 1 over x. It's the indeterminate form of x raised to the infinity raised to the 0. But no matter if it's infinity to the 0, 1 to the infinity, 0 to the 0, the procedure is the same for all of these. What is our first step? Step 1 is let y equal the function you're taking the limit of. Step 2, take the natural log of both sides. The natural log of x to the 1 over x. Use the properties of logs, this on the right side. So using the properties, we can bring the 1 over x down in front. We get this. Now take the limit. In this case, we're taking the limit to infinity of both sides. So we have the limit as x goes to infinity of the ln of y equals the limit as x goes to infinity of 1 over x. Actually, let me just multiply this. If I multiply that, we get the ln of x over x. This step here if I just multiply, when I go to infinity, I get infinity over infinity, so I can directly use L'Hopital's rule. But here you might need to manipulate this. Like if this was x times ln of x, we would want to write it as the ln of x over 1 over x, right? The reciprocal, right? So so that's the only place where you might have a little bit of a struggle, yeah, if you will. But at this step, we've got to have either 0 over 0 or infinity over infinity to use L'Hopital's rule. When we take the limit, it is infinity over infinity, so we can apply L'Hopital's rule to the right-hand side. And when we do that, well, the derivative of the natural log of x is 1 over x. And the derivative of x is 1, but 1 over x over 1 is just 1 over x. Now when x goes to infinity, 1 over infinity is 0. So we get the limit as x goes to infinity of the natural log of y equals 0. Now here, just remember, technically, we should rewrite this as the natural log of the limit as x goes to infinity of y. It's a technicality here. The reason why is because at this step, we're going to do e raised to both sides. Why did I want to do this? Because remember, there's a rule that says e to the natural log of any power a is a. Well, now this is written in the proper form. E to the natural log of this limit is just that limit by this property. So the limit as x goes to infinity of y is e to the 0, but e to the 0 is 1. Well, now the last step is just go back and plug in what is y. That's what we did this at the beginning. Y is the function that we're taking the limit of, so I just substitute it. So the limit as x goes to infinity of y is x to the 1 over x. Well, as we found, that limit is equal to 1. So that's the procedure of doing these limits in these indeterminate forms, such as infinity to 0.